Hello, my groovy class. I only say that because it's time to be radical. Anyways, some of you will get that. If you want to turn in your books to 274, we're going to start chapter number 8. Now, I'm doing this video for Monday. You should have your work sent home, and you should find a test over chapter number 7. You can do that sometime this week, all right? And so I'm going to basically just do a couple lessons this week, but make sure you take your test because that's one of your days. So make sure you take that test. Here's the good news, and if you need your parents to hear this, here's the announcement. You may use your book, open book test. All right, so that is fine. You can look up. Most of it's just working out things, but if there's something you need to refresh on, especially since you haven't been in a classroom, I'm good with that. All right, so Chapter 7 test has been sent home with you. Make sure, or will be sent home with you, and make sure that you take that test. All right? Again, your parents have to sign it that you didn't cheat, which I don't really know how you can cheat unless you Google it, which I probably just told you how to do that, so there you go. All right, but chapter number 8, page 274, we're going to do radical expressions, dude. I know, I'll quit. All right, but it's roots and radicals. Sounds like a board game that's terrible. Hey, play some roots and radicals, but no. All right, so here we go. If you want to look at that page, we're going to talk about a few things. We're going to talk about what a root is. Now, most of you know we've talked about square root. And what that is, when you see this sign, you're going to find the root. It looks like a check mark, basically, but it's called the radical sign. So again, this right here is called, this big old check mark, the radical sign. All right, whatever's inside the check mark, in this case the 8, is called the radicand. All right, radical sign and the radicand. All right, it's not the radicannot, it's the radicand. All right, and then this little symbol right here is called the index. In this case, it's 3. Normally, if you see one without an index, it's always understood to be 2. All right, so like I said, this would be called the square root of 4. In other words, what multiplied by itself twice will get 4. And the answer to that is 2. All right, so that would equal 2. If I said the square root of 25, what number multiplied by itself 2 times would give you 25? And the answer is yes. Nice job, 5. All right, so that's the square root. In this case, this is the cubed root of 8. So again, the index is the little number, and then the radical sign is the check mark. The radicand is what's inside of that. In this case, what number multiplied by itself 3 times gives you 8? All right, and we know the answer to that to be 2, because 2 times 2 is 4. 4 times 2 is 8. All right, so multiply by itself 3 times gives you that. All right, the cubed root of 64. The cubed root of 64 would be 4. All right, because 4 times 4 is 16. 16 times 4 is, you get it, 64. All right, now you might see other things. You can have, this means the square root. If you have this and it has a 3, you're going to say the cubed root, or what number multiplied by itself 3 times gives you that. You can do the 4th root. What number multiplied by itself 4 times would give you that? 2 times 2 is 4, 4 times 8, 8 times 2. So the cubed root of 16 would be 2. Right? Or you can do the 5th root, the 5th root of 32. All right? Which again would be 2. All right, what number multiplied by itself 5 times would give you that? All right, so you get these different roots, but the index will always tell you how many times you're multiplying by. Index, radical sign, the radicand is what's inside of it. That's pretty simple. All right, so look over there at your book and let's read a little bit. All right, roots and radicals. All right, it starts out by saying this: components of radical expressions. Please look down at your book and read this with me. Previous chapters have almost exclusively discussed rational numbers. However, algebraic operations may result in values that are not rational. Unrational numbers are numbers that will not end up with a whole number or an ending decimal, like pi, 3.147 or whatever. That's an irrational number. It never works out. What I'm jumping to is the square root of 2. There is no square root of 2. It would be like I don't know what it'd be. All right, that's why it's irrational. All right, the square root of 3. I have no idea. Somewhere between 1 and 3, but it's irrational because it never would actually work out. We'll keep reading. To find the root of a number, reverse the operation of it being squared. So 2 squared equals 4. So the square root of 4 equals 2. It's just the backwards of squaring a number. All right. Next paragraph. To express roots, you're going to use a radical sign. We talked about that. Then inside the radical sign is the radicand. We've talked about that too. And then the number written in the crook of the radical sign is called the index. Yes, we've talked about that too. All right, and so you can see that little chart at the bottom down there. Express the meanings. So 2 squared equals 4. Or, look down at the chart, the square root of 4 equals 2. And you would say that the square root of 4 is 2. Jump down to the end. 3 to the 5th power would be 243. The reverse of that would be the 5th root of 243 is 3. Or what number multiplied by itself 5 times would give you 243? And that answer is 3. Next page. 275, top. It says, since the squares of the integers from 1 to 20 of the cubes of the integers from 1 to 10 are commonly used in algebra, it would be helpful to memorize these values given in the table to the right. Yes, you have to memorize these. Knowing these common squares can be especially helpful in approximating a square root. Now, see that old chart? You are going to have a quiz on that. All right, I need you to memorize those. Next week on Monday, you'll have a quiz on these. So make sure you memorize these. I'll try to remind you as we do these videos, but you must memorize that table. And what I'll ask is, like, I'll give you, like, the first question we'll see, what is the square of 3? What is the cube of 3? Or I could tell you, what is the square of 16? Now, you can do the math. I get it, all right? But part of the instructions will be your parent, all right? Your parent's going to give you the quiz, and you only have 5 seconds to write down your answer for each one. I know, right? But that's the only way you can do it, because otherwise you can work it all out, and that just defeats the purpose. You have to have it memorized. All right, but once you know these, you can pretty much figure out everything. Like if it asks you for the square root of 30. Well, I know 5 squared is 25, 6 squared is 36, so the square root of 30 is somewhere between 5 and 6. Now, again, that would be an irrational number, but we'll talk about it later. Then go down there, paragraph under the yellow box. It says, recall that a rational number is a number that can be expressed as a ratio of integers. An irrational number, on the other hand, cannot be expressed as a ratio of integer. If an integer is not a perfect square, it's irrational, such as 5. What is the square root of 5? No one knows, right? Because it would never work out. It's irrational. The principal root, all right, the principal root is always the positive root. So if they ever ask for the principal root of 36, the answer is 6. Now let me just write a few of these things down, kind of explain what I'm saying here. All right, because what they can do is they can do this. What is the negative square root of 36? And that would be negative 6. All right, so when they put that little negative on the outside, what they cannot do, at least in Algebra 1, is they're never going to ask you for the square root of negative 36, because there is no square root of negative 36. There's nothing you can multiply by itself to give you a negative 36. Because you multiply 6 times 6 is 36, and negative 6 times negative 6 is still a positive 36. So there is no negative. But if they do want the negative square root, if it's on the outside, just work it out the same way and write down the negative sign on the outside there. It's pretty simple. All right, but that's called when you have the positive square root. All right, so if I want the positive square root of 36, all right, it's 6, and the positive is always called the principal square root. Just means it's positive. Principal, remember your principal is always positive. I think he is, unless you're drinking a Gatorade. All right, so go back over there to the next page, on page 276. Sometimes you can deal with what's called the quotient rule of radicals. The quotient rule of radicals means this, really simple, right? It means you're finding the square root of a fraction. All right, so if I have the square root of 25 over 36, all right, you say, that's hard. Not at all. All right, you're just going to take it into 2. What's the square root of 25? What number multiplied by itself gives you 25? 5. The square root of 36? 6. So the answer to the square root of 25 over 36 is 5 over 6. Simple. All right, so, that should be easy enough, I would think. All right, if sometimes it doesn't work out exactly, if you look at the little box 8.1b, all right, it gives you 49 over 121, all right? Again, the square root of 49 over 121, the square root of 49 is 7, square root of 121 is 11, so 7 over 11. But they give you another illustration. The square root of 1,540 over 100. Now, I can do the square root of 100. That's 10. But the square root of 1,540 doesn't really exist. All right? There's not a number that will multiply by itself to give you that. So what you have to do is you have to make it into a decimal, all right, by taking 1540 divided by 100, which gives me 15.4. The square root of 15.4, I don't know. There is no square root of 15.4, but I know it is somewhere between 3 and 4. 3 is less than that, but 4 would be greater than that. Because the square root of 3 is, the square of 3 is 9. The square root of 4 is 16. So somewhere between 9 and 16 is the square root of 154. You don't have to do many of those, but that's all that means, right? So it's pretty easy. If you have letters work out pretty much the same way. If you have, for instance, the square root of x over, we'll do 10 over y to the 12th, right? X over 10, y to the 12th. Now remember, when you're finding with letters, it's not just, you're adding the exponents. That's the only thing you really have to remember there. So, in other words, what would you have to multiply by itself twice to get x to the 10th? And that would be x to the 5th. Right? And then y to the 6th. That would be the square root of x to the 10th over y to the 12th would be x to the 5th, y to the 6th. Because you have to multiply x times 5 times x times 5 to give you x to the 10th, y times 6 times y times 6 to get y to the 12th. So x to the 5th, y to the 6th. That's not difficult either. So, all right, so in review, you have the radical sign, you have the radicand, you have the index. All this means is what multiplied by itself gives you this. If your index is higher, if it's 3, what multiplied by itself 3 times would give you that answer. If it's 5, what multiplied by itself 5 times would give you that answer. That's all we're doing. Okay? So this really isn't difficult. So turn over to page 278. Let's do a few of these, and hey, another class done. So I surely didn't expect to have to do this year, but it is what it is. All right, so turn over there to page 278, and we'll look at the first one. All right, so here we go. First of all, we're going to find the square on numbers 1 through 14. What that means is you have to multiply it by itself. So if the first one says 9, if you find the square of that, the answer would be 9 times 9, which is 81. All right, if you jump in the middle, number 8 says 20 cubed v to the 9th. All right, which would equal, you'd have to multiply 20 times 20, which would be 400. Then q cubed times q cubed will give me q to the 6th. Remember, you add your exponents when dealing with letters. And then v to the 9th times v to the 9th would be v to the, anyone? 18, all right? V to the 18th. All right, so if you have a fraction, like down there, number 11, says 12 to the 13th. 12 times 12 is 144. 13 times 13 would be 169. See, just multiplying by itself. All right. So if you have the decimal, again, that one's going to be a little bit odd. Odd is just a lot of zeros. It's not hard. But if you have like 0.05, you just multiply by itself. 5 times 5 is 25. I have 4 zeros. 1, 2, 3, 4. So the answer to number 13 is 0.0025. All right. So that's the first one. You're going to square those. Numbers 15 to 30, you're going to find the principal square root, which means all these are positive. That's what principal square root means. All right, so if you're finding the principal square root, if the root cannot be found, then you're going to write irrational. And there are 2 irrationals in here, right? All right, so we look at the principal square roots. So the square root of 100, what number multiplied by itself gives you 100? The answer is 10. It's pretty easy. We can go on. Those are pretty easy. Number 19, I'll give you one of them. Number 19 says the square root of 65. What number multiplied by itself gives you 65? Well, if you do 7 times 7 is 49. 8 times 8 is 56. 9 times 9 is 81. So we know it's not 8. We know it's not 9. So it's somewhere in between, which means that it is irrational. All right? So you'll write that down. Irrational for that one. If it has the letters in there, like number 24, number 24 says 144 x squared z to the 6th, the square root. The square root of 144 is 12. What is the square root of x squared? X times x, so just x. And then the square root of z to the 6th would be z cubed, because z cubed times z cubed is z to the 6th. All right? The decimal ones, number 29 and 30, is what you know, like for 25, number 29, to get 0.0025, you know that it has to be 5. But how many zero? What's the decimal going to be? You have to figure that out. The same thing with number 30. You know 3, so that 9. But what would you get? If you just multiply 0.3 times 0.3, you're going to get 0.09. Well, I need 0.0009, so you have to figure out how many decimals to put in there, right? Then on numbers 31 to 38, you're going to find the cubed root. All right? The cubed root. That means what number multiplied by itself 3 times will give you the cubed root. Now, these you can have. Now, by the way, in those principal square roots, if you have like negative 16, all right, that's irrational because you can't have a positive square root for a negative number. Now, if it's cubed, you could. All right, like if I will need the cubed root of negative 8. That actually works because what number multiplied by itself 3 times would give you a negative 8? It'd be negative 2. That would be the answer. Because negative 2 times negative 2 times negative 2, negative times a negative is a positive, positive times a negative is a negative, 2 times 2 times 2 is 8. So this would actually be negative 2. So you can have the negative on the inside of the radical sign when you're dealing with cubed roots or any odd index. That's the index. So 3, 5, 7, 9, 11, etc. All right, so you can't have that in these. So just if you see in numbers 31 to 38 a negative inside the radical sign, don't be like, well, that don't work. It actually can. All right, matter of fact, all of these have an answer, right? Most of them are negative. All right, so the first one says, what is the cubed root of 27? What number multiplied by itself 3 times gives you 27? And the answer is 3. All right, because 3 times 3 times 3 is 27. Okay, we could go on, like number 33. Well, I just did 33. Hey! But it says the cubed root of negative 8, which would be negative 2, because negative 2 times negative 2. 34, the cubed root of negative 1. What number multiplied by itself 3 times gives you 1? 1. And of course it has to be negative, because that's on the inside. I'll do 38 with you, and then I'm done. All right, 38 says the cubed root of negative 343. What number multiplied by itself 3 times gives you 343? Now, I've already told you all these work out, so there is a number. All right, so I know it's going to be negative. So you say, how do I figure this out? Well, just start with a random number. Do 5. 5 times 5 is 25. 25 times 5, if you want to work it out, 25 times 5 is 125. So it needs to be larger than that. So if that was 5, let's try 6. 6 times 6 is 36. 36 times 6 would be 18, 216. I'm still not there. So let's try 7. 7 times 7 is 49. 49 times 7 is 343. So that's it. All right, so negative 7 would be the cubed root of negative 343. All right, so again, this lesson isn't too difficult. You're just working, and we should have, in math last year, done some of this too. So again, if you'll work out lesson, all right, 8.1, I want you to do all the practice problems. So 1 through 38, which we've already done a bunch of them. All right, so 1 through 38, that's all I want you to do is the practice problems. This is for Monday, April the 6th. All right, and then at some point, I will do a lesson for the 7th, and I will do a lesson for the 8th. That's all I'm going to do, and you can bump those. You can do those lessons. I'll bump it a day, but I need you to do the test this week too. Okay, so do the test and do this, and then I'll have 2 more lessons for the remainder of this week. Okay, if you have a question, please contact me. You can text me. All of you have my text number, I'm pretty sure, because I've been texting you. You can Instagram message me. You can email me, tburke@cba.kazadl.org. You can, whatever you need to do. Just get a hold of me if you need me. I think y'all can handle this, all right? If you need to go back and watch something again, do it. But you can do it. I have confidence in you. Remember, this lesson is radical.